All right, so looking ahead, test on Friday. It'll be 2 free response questions. And so you'll have the full time to work it. You guys at home, I'll give you an hour to work it. But in theory, it should take 30 minutes because it's 2 free response questions. Today we'll do 1 free response together, and then I'll let you work on the other free response in class. And it's a motion one, and they're pretty straightforward. Like, I feel like today's you should maybe not get all the points, but get a big chunk of the points off of the motion ones. So let's look at the packet. Topic 7, horizontal and vertical. And last period they wanted to call it the emotion topic. I don't know why they thought that was funny, but rather than just motion, we're dealing with emotions today, apparently. A little bit at the top on the AB exam, obviously the one you're taking. Horizontal and vertical motion problems are FRQs as well as multiple choice. You don't really need to know this, but maybe it gives you a little insight. On the BC exam, they likely don't have these, basically because BC does more about motion, like parametrics and vectors, and so their free response question about motion would likely be something a little harder than we have to do. If you look at the 2 examples, one's from 2018, one's from 2017. So these are fairly common. And again, there's tons more. I'm not going to give you every single AP problem ever released. But this illustrates that they're pretty common. And they can be calculator or no calculator, just depending on how AP wants to test it that particular year. So we'll do number 1 together with the calculator, and then you'll have plenty of time in class to work on number 2 together. And again, these are questions where you can get all the points, or at least most of the points. So number 1, a particle moves along the x-axis with velocity given by. Okay, so this is the velocity. Again, I wouldn't have to write it down on test day, but it's good to slow down your brain and think about it. So even before I move on, I'm thinking velocity. Okay, so if I want acceleration, I would take the derivative of velocity. And if I want position, what would I have to do to velocity? The antiderivative. So, I mean, who knows what they're going to ask, but something along those lines. With the antiderivative, though, I'll have to be careful because I'd have to have either figure out what C is or have 2 spots and integrate from 1 to 2. So there's some sort of change in position going on with that one. Now, I don't know that I'd take the time to write that while I'm taking the test, but as soon as I see velocity, I should probably pause and think this stuff in my brain, because that's probably what's coming. Now, I did this problem last period, so I know what's coming, but that's always going to be what's coming with a position, velocity, motion type equation or problem. The particle is at position x equals -5 when t equals 0. Another way to write that would be x at 0 equals -5. All right, all of that is pre-information. Actually, that probably goes with this. When we integrate, we'll have the starting point. Okay. Again, it's probably worth it to slow down while you read the question. I know you're hurried, you think I got to get through this, I need to get to the actual questions, but if you take a little time to make sure you process, understand what they're giving you, then it will make the rest of it go a little smoother. So pay the price and time initially, because it'll pay off later on. Find the acceleration of the particle at time 3. Okay, well, we already were thinking to get the acceleration, I need the derivative of the velocity at t equals 3. And this is a with calculator problem. So they want you to use your calculator. They really don't want you to take this derivative by hand. I mean, you know enough you could do it, right? It'd be quotient rule and trig rule and chain rule, but that's not what they want. They want you to just use the calculator to do it. And since I did it last period, it's already in my calculator. I put it in for y1 because I'm assuming I'm going to have to use that equation multiple times. So rather than have to type it in multiple times, I type it in for y1 and then I can go from there. Or I can just use y1 whenever I need it. I don't have to graph it, but maybe I want to graph it. I know it needs to be 0 to 3.5 for the x-axis. And the y-axis, I cheated. I played around with it last period, so I have a decent looking y-axis there. Kind of just pausing to give you time to type in the y1. So how do I find the derivative at 3? So there's two options. I can, if I'm out of that and I want to go math 8 for derivative, math 9 is integral, so you'd figure it out if you hit it. So dx.
Do math 8 and then put in the velocity so you can get the derivative.
Correct. So the derivative of y1, which is the velocity, at x equals 3. And I'm a little surprised there's absolutely no units in this problem, so I don't have to worry about it. But most of you guys have had physics, probably all of you, so it'd be meters per second squared or feet per second squared or something like that. Maybe that's why they left it off. They figured it's an easy one. You'd be okay with units on that. By the way, the other way to get the derivative is on the graph itself. Second calc, dy dx. And then you could type in 3. And obviously it's the same thing. But it also locates it on the graph. Maybe helps you visually see that, yeah, the slope is negative right there. Our tangent line would be pointing down if we had one. So at least two ways to get the derivative from the calculator. Part B. Find the position of the particle at time equals 3. So find x of 3. Okay, well we already said we'd need to integrate velocity to get position. But what should I use for my limits? I want to do 0 to 3 because that would be x of 3 minus x of 0. And if I move things around, x of 3 equals x of 0 plus integral from 0 to 3 v of t dt. This is a specific application of this start plus accumulation. Oh, online people, I still need to put this on for you guys. Start plus accumulation. We start at x of 0. We'll accumulate, and that'll put us at x of 3. So x of 0, they gave us, that was negative 5. That we can put in the calculator. There's two ways to do it. We've done math 9 before. I'll do it that way first. Math 9, so 0 to 3 of y1 dx. And again, they know you have a calculator. They don't expect you. In fact, you wouldn't be able to actually do that thing by hand. And I would safe stop that, leave it alone. In fact, safe stopping, in some ways it's helpful. This is showing that we started at negative 5 and we went 3.24 away from there. and we can leave that as our answer. The other way I wanted to show you can do that is you can do it on the graph as well. So let's see, second calc, all those options we've done before, but you can also integrate on the graph. By the way, when you integrate a graph, what does it tell you about the graph? So this is sort of separate. Area below the curve. So watch what happens when I select integrate when I'm on the graph screen. Lower limit, I want to go 0. Upper limit to 3. So it's going to integrate from 0 to 3. And it even shows you, it's like, hey, remember integral is the area under the curve. So it kind of shows you the visual of what's going on. Maybe that's helpful. The only thing I don't like is I don't know how to get the area off of there. It's like now it's shaded, I'm stuck with it shaded. Other than that you can change, if you just change a little bit of something, so 3.5 to 3.6, then it has to redraw the graph and the area won't be there. I don't know how else to get it off of there. I'm sure there's a way. So Math 9 is great. But if you want to get a visual of what's going on, you can do it on the graph page as well. Part C, evaluate integral from 0 to 3.5 of v of t. That should be easy. That's almost what we just did. And then the same thing, but with absolute value bars. And then interpret the meaning of each integral. Well, I can definitely do the integrals. In fact, I can do one of them right here. Integral from 0 to 3.5. is 2.844. We could discuss what that means now, but it might be easier if we found the other one and kind of discuss them in comparison to each other. So I can't do the other one on the graph because I need to do the absolute value. You remember, do you know where to find the absolute value button on the calculator? Math, num, abs. And then as long as you have a reasonably new calculator, it'll put the absolute value bars. If you have an old calculator, it's in the same spot, but all it says is abs. You have to deal with, it means the same thing. It's just a little bit nicer when it's got the bars there. y1 dx. You really have to think on that one for a little bit.
The first one should be 0 to 3.5, not 0 to 3.
You're right, except that was from the previous problem. So this one's correct. So 3.737. So what do they each represent, or maybe just why are they different, and that would maybe help explain what they each represent. Okay, so the first one had, looking at the graph is helpful. The first one we subtracted some. The second one, if we took absolute value, that piece would be up here and it would be all positive. It's distance versus displacement is exactly right. So which one's which? Now, you can figure that out because one of those is always going to be.
The first one is total displacement.
First one is displacement. I don't know that total is even necessary. And I don't know how many words they want. They may just be looking for displacement. After that, displacement of particle from t equals 0 to t equals 3.5. And the second one is total distance of the particle from t equals 0 to t equals 3.5. But my guess is, as long as you got displacement and distance on there, I don't know, that's probably one that they would discuss and say, if all they said was distance and displacement, would they get the full point? I don't know. I mean, I know this is probably what the key says, but if you left off from t equals 0 to t equals 3.5, would you still get that point associated with that? I don't know the answer to that. Don't leave it to chance. Part D. A second particle moves along the x-axis with position given by x2 of t equals t squared minus t. Also from 0 to 3.5. At what time are the two particles moving with the same velocity? So when does v2 equal v? It's a little bit weird. We didn't call that other one v1, but I guess it wasn't necessary at the time. When does v2 equal v? Well, what's v2 equal? Yeah, just 2t minus 1, the derivative of x. So I want to know when 2t minus 1 equals, I'm not going to rewrite that whole thing, I'm just going to say equals v of t. So how can I figure that out? Just put them both on the graph and find the intersection. One graph's already there. The other graph is just 2x minus 1. And here's where the shaded thing, I don't know, I find that annoying. I can't tell where they intersect because it's shaded. So I'm going to go change my window just a little bit so that the shading's not there anymore. So there's the first one. There's the second one. They look like they intersect at one spot. Again, you don't want to spend the time doing this, but if we had a little bit better x scale, it'd be more obvious that they only intersect in one spot. So second calc, intersection, first curve, second curve, guess. So they intersect at t equals 1.571. I don't want to say that's an easy problem, but as far as FRQs go, I feel like that's pretty straightforward. Like I would hope everybody gets, 7, 8, 9 of those points. That's a good problem to rack up the points on. All right, with the rest of the time, I want you guys to work with each other and do number 2. It's no calculator, so you'll have to take some derivatives by hand and maybe an integral by hand. But try number 2. I think you'll have time to finish it. By the way, I'm looking at the timer down here. It took us 19 minutes, but I started with some introductory remarks that may have taken a few minutes. And we went really slow. We did derivatives multiple ways. We did integrals multiple ways. We explained and talked about things along the way. So again, usually time isn't an issue. I mean, knowledge might be, but if you know what you're doing, usually it's not a super time crunch.